Hey everybody, I wanted to make a video about our generator install. Maybe kind of lead you through some of the questions that you guys have had, some of the questions that I had trying to figure out what I needed and how this was going to work, and kind of how to plan for the future and those kind of things. So we'll start out by taking a look at what we've got as far as our breaker boxes in the house, kind of show you what we have and why it's where it's at, and we'll start there and we'll kind of work through the generator steps and see if we can't answer some questions. The first thing I wanted to talk about was we've got a 400 amp service in this house. The box here on the right, this has everything that has to do with the lower floor and the upper floor, but basically just inside the house. This other box, it kind of has to do with everything outside and everything in the garage. So kind of wanted to explain to you why these breaker boxes are where they are. First reason they are where they are is this kind of where I wanted them. I would have moved them a little further in, but they needed to be within 5 feet of the meter base because we don't have a disconnect on the meter base. So they had to be pretty close to the meter base. And to make that happen, if you were paying attention, the main breaker is on the bottom. With the way it came in off the meter base, if I had flipped them over, what you kind of call the standard way, the wire coming in would have been almost 7 feet long, and they want it within 5. Hopefully that kind of shows you what this looks like in here, and we'll move outside and we'll talk about the meter base and the transfer switches and then on to the generator. So hopefully, if you have any questions, just comment. I'll get back to you and try to answer any questions. I'm not an expert on any of this. I had to figure all this out myself. I had good qualified electricians hook all this up, but I wanted to understand what I was getting into, and I wanted to know something about it. I just didn't want to go out and find somebody right off the street to just hook this up, somebody I didn't know, and I wanted to be able to kind of make sure that what they were doing was going to be, pass inspection, was going to be something I felt secure with at night. This is probably not a project that you want to tackle yourself, but you can do a lot of things up front to help you and help them along the way. So you can kind of have everything kind of ready, know what the answers are to your questions before they get here, because they're going to ask you certain things about placement. They'll point out things about where code insists on it being. There's certain things you can't put it in front of, you can't put it so close to. So let's go outside and we'll go through some of these. Local codes are going to vary from one location to another, but this will kind of give you things that you can look to and go, well, what is that code in my area? So you're not looking blindly for codes, and you can get really overwhelmed in what's really important. One of the things is that the generator itself can't block the disconnect. You can't have these switches behind it, and your gas shutoff needs to be accessible. So you have to put it so far from the wall. Here they call for 18 inches and about 3 feet from the door. So, you've got to kind of locate where you're going to go. And we had kind of planned that out. We knew that this generator was always going to be something that we wanted to add, but we didn't put it in when we built the house, and really it would have been better had we. It just would have made it a little easier. But anyway, I'm going to go ahead and get these panels off, and then we'll walk through, what's what and kind of what's inside these switches. So these are your wires coming from your meter base. These are the wires going back into your breaker box. So this switch, that's just a disconnect, to break power to the house. Right up in here are 7 communication wires. These top 3 wires will go to the secondary transfer switch. And then these bottom 4, they will go directly to the generator. And I'll show you that in a minute. But basically what happens is when This switch senses that we've lost power to the house. It kicks this solenoid and it causes the generator to start just a few seconds later, and then a few seconds after that it'll throw power to the house. So I think we figured it was about 20 or 30 seconds total that all that takes place from the time you lose power till the time you get power back. The other part is right here is where we spliced everything to go down to the secondary switch and on down to the generator for these three wires that I was telling you here. These three go to your secondary switch and then onto your generator. So it's just these four directly that go straight from here to the generator. So no splice, no edited wires to that. And I'll show you a little bit more on that in a second. But this is our basic first transfer switch. This is a 200 amp transfer switch, and the second one is a 200 amp also. So let's get a look inside that one. So this is our secondary transfer switch, that's what I'll call it anyway. And right here you see these three wires. These are the three wires I was talking about a minute ago that come into this switch. And that's all that it requires to hook these two transfer switches together. And then what we've done is we've come down into a junction box here, and we've brought wires from the secondary transfer switch, wires from the first transfer switch, and we put them in these multi-tap lugs, these insulated multi-tap lugs, and then continued them on to the generator through a flexible conduit. So here's our connection to the generator. These right here are our main lugs. They come in here real close. And this is why I think it's important to use copper wire when coming from your transfer switches to the generator, is these lugs are not big enough for the aluminum wire. Aluminum wire to carry this much amperage has to be much bigger. So we chose to use copper. It kept us from having to use an adapter lug. But you have your two hot legs, your neutral, and then a ground back here that you probably can't see very well. What's important to know is these are the three wires that go to both transfer switches. They're bonded together and they attach to both transfer switches. Back in here are the four that don't. And of the four that don't, at the very top there's an N1 and an N2. And those are the lugs that you tie your cold weather kit into, or your extreme cold weather kit, depending on what environment you're in and what you think you need. But they plug into just another slot on the N1 and the N2, and that gives you 240 volts of power to go to your accessory heaters, battery pad, oil filter, and on the extreme weather kit you'll have an intake heater that goes into kind of your air filter box. Where we're at, the cold weather kit was plenty, but here's those two lugs, and here's the wires that come off of them. There's two that go to the oil filter, and then these two here, I've routed them around here, and they come down, they go to the battery. So there's a larger pad here underneath the battery that keeps the battery warm when it gets down below 40 degrees. I don't know that it's necessary, but we put it on anyway. So let me run you around here. Here's what the battery heater looks like. It's kind of a bear to get on there. It's kind of a squeaky fit. But anyway, this is 240 volts. These two wires are 110 a piece, and this thing has its own little built-in thermostat that knows when it's cold enough that it needs to kick on. And let me show you real quick here. There's a grommet here that you can slide those through. The set actually comes with some tie straps that you can kind of secure it to that all the way down around, keep those two wires away from the motor. The other part of this is your LED screen. As you can see, it says ready to run, hours of protection. It gives you the hours that this thing has been green lit, ready to protect the house. So it's not been hooked up very, very long, so all this is really fresh in my mind. You have to connect this via Wi-Fi, which was a little tricky here at our place because of the way the two Wi-Fi connections work between the phone app and the generator. I don't have any other service, so if I don't have electricity to the building to run my Wi-Fi, I've got nothing. I can't call anybody, I can't look anything up. So my hookup was a little different. I had to call tech support. They gave me a password and we got through it very simply. They were very nice to talk to. They were very helpful, and it was maybe a 3-minute phone call total. So anyway, the instructions, and it's a walkthrough thing where you press one button that leads you to another button, and you just keep pressing buttons and making settings, and it will actually hook up to its own time, so you don't have to, time everything. Something I wanted to say before I ended this video was that in my mind, this is something that should be done by a qualified electrician. There's nothing wrong with knowing how it works, how it's wired in, kind of the basic principles behind it all. Just, if nothing else, just to make sure that you're getting a good job when the guys come out to do it. But there's a risk that a generator can backfeed back down the power lines. I don't really understand all that, but I know it's a possibility. And we want to make sure that all of our utility workers are safe when they come out to make a repair, to work on our lines or do maintenance. And you just don't want to take any chance on putting anybody's life at risk, utility workers or your own family. So I would recommend finding somebody qualified to do all this for you. But at least this will give you an idea of what to look for in codes, your placement. Mine is setting on gravel right now that's compacted. Eventually we're going to concrete this, and that's why it's not on a more substantial pad. Some of the things that you might ask is, how much does all this cost? Ours is a 26 kW generator. It came with one of the transfer switches. You can expect to spend, $7,000, $7,500, depending on what area you're in and all that. The extra transfer switch, you're looking at another $800, $900 there, and all the wires and labor and all that stuff probably going to run you somewhere in the neighborhood of $5,000. So you're pretty easily looking at a pretty solid $12,000 to $13,000 for a whole house generator. That doesn't mean you can't get it done cheaper, can't buy it cheaper, go with a smaller model, this or that. That just kind of gives you a ballpark. You can't hold me to anything, but that's probably where you're going to fall, unless you've got a buddy that can help you out. If you're just an average guy wanting to do it, that's about what it's going to run. And I can't be happier with it. It exercises every couple weeks for a few minutes, and we've actually powered the house down and have it kicked back on. Real happy with it. So we'll just see how it goes in the long term. But where we're at, if I don't have electricity and I don't have internet, I don't have any connection to the outside world. I don't get any cell phone reception out here. So for me, it was kind of a must. Just not just for convenience, but safety too. If something goes wrong, I need to be able to get a phone signal to get out of here. So anyway, if you got something out of this video, please give us a thumbs up, subscribe. I'd like to see you back. Hopefully we're putting out a little bit of content that somebody's getting some good out of. So anyway, thanks for watching, and we'll see you in the next video.